requirements engineering. This is a very easy course, and I hope we'll be moving together. Or at least, I hope we'll be moving together and understanding most of the concepts that we'll be talking of. So, like I said before, Metro Marufu is present is stated Apple. Oh, that's a mistake. So, our course is called Requirements Engineering. Does anyone have an idea of what we'll be talking about when we're saying requirements engineering? I know you guys have read Sakamusata.
The requirements engineering then inenge ndekutsvaga kuti client yedu iri kuda zvakaita, and then we document zvichidiwa neclient.
Okay. Anyone else? Anyone else to give it a try? Marcos, saka makanyora chiko mu assignment you guys. All right, I'll give you a simple analogy before we proceed so that you understand exactly what is needed. Exactly what is not what is needed per se, exactly the concepts that are there. All right, chese to Zimbabwe and it.
Yes.
Except Mpumi.
Yeah, and Zimbabwe in
No. Okay. So you might not understand, but I'm sure you've got an idea.
Yeah.
I've got, let's say I've got Van Vemati. So I've got someone who is looking for, let's say, 200 US dollars. I've got someone who's got $200 and is looking for RTGS or bond. So what you then do, you want the $200. So it's up to you now to find Mono to buy that $200. Are we together so far? Hello, are we together?
Yes, we are together.
So I'll go Muma Streets, ask for guys. I've got $200. Does anyone want to buy $200? Then when you want to, but there's someone who's got let's say 2,000 pound, 2,000 pound. Then when there's a kuna middle, kuna the guy in the $200. I've got 2,000 pound. The person who can either accept or decline it.
Yes.
Depending on the rate of the day. So basically what requirements engineering is, you'll be acting as a middleman. So this middleman would go to the user, get specifics on how the system is to be built. Then up by Papo, or either analysts or developers. So it's important for you to understand each and every requirement. So from our example, let's say muna $200 okuti kuda mari ndio uenda unopiwa RTGS, but the person wanted maybe bond. So it means now you need to go back. Utaiwa no achada RT, askuda RTGS after bond, also pure bond. That becomes a bit of an inconvenience. And when we're talking of now building system, that could be a very costly decision or miscalculation on the mind. So basically, unongori middleman moving from the client to the guys who are going to be developing, which are the exact specifications of what the system that you want to develop is going to be all about. Because bear in mind that you can have a system, let's say, I like giving examples, real life examples, so that you guys understand. You want to travel I'm from Wanke, going to Harare. And your specification just says, I need something that allows me to travel to Haran. How many means of transport do you know? We've got trains, we've got planes, we've got buses, we've got magonyet, and we've got taxis, and we've got private cars. So you need to now write a report which is very specific. No, you guys, this person, with the client that I have, needs a car which accommodates 7 people, which is 4x4 and off-roader because of nature of the things that is going to be carrying. And it needs to be a diesel engine because he is from maybe petrol trade and he's given coupons the diesel. So all that becomes somewhat requirements engineering because you know exactly what the client, you should find a way to gather exactly what the client wants. If you can go in there, you can go to no, this guy wants means of transport from point A to point B. It ceases not to be enough now because what kind of transport? I can, if you're to design that vehicle, munhu design a plane, more design a train, yet munhu anogona kunge uri one angori simple parcel. So zvimwe zvacho zvese becomes overkill. They will not be fit for purpose. Are we in agreement?
Yes, sir.
So basically that is what we are trying to say. We're simply trying to get the actual specifications, actual details of that system to the developers, so that it's easier for us to make alterations or changes to the specifications before the system is built. Imagine your ones tigadzirire mota wogadzira bus. Are the changes going to be easy, or it's now going to you have to tangidza kutogadzira?
Zvinozongopedzisira zvakutobuda mubudget.
So the lot of ways to look at it, because if you it becomes very key, because if you have wrong specifications, you end up developing a system that the client will not want. It might, in your view, and it might do what you think the client wants, but it does not mean that's what the client wants. Like I gave you in the example, your mode of transport. Your mode of transport, your ideal mode of transport is maybe designing a car, but the person has got maybe 30 tons of coal that they want to ferry. So a car would not be fit for purpose, although it gets you from point A to point B, but that car will not be fit for purpose.
Yes.
So since that is what we'll be trying to do for requirements engineering. But since this is strictly academic, makufana kutipa ma textbook definitions. Textbook definitions.
Yeah, this was.
So let's start with this. English, it's not it. What is a requirement? What are requirements? Start from there. I've given you the basic outlook of what we will be doing and it. So now we want to understand it on the academic point of view now. What are requirements?
Requirements, that are descriptions of the services provided by a system.
In and want to be more my definition in text. What it means. I need you to understand what you're saying. Matichi is saying. You said it's what?
I said these are descriptions of the services required by a system.
Requirements, but this system requires something. This is the requirement of this.
Okay, I'm saying these are descriptions of the services that a system will provide.
Oh, okay. I wanted to start off from an English perspective, then we narrow into something that's more IT.
A requirement to read.
Yes, like utikati isusu anditi, a car requires fuel to travel for it to move.
Yes.
And it requires a battery. So what is a requirement?
A requirement is a need. It's something that it cannot do without.
Very good. Now takutaura zvinhu zvamunonzwisisa. So we're saying it's something chekuti it's a need. Without fuel, a car cannot drive. Without wings, a bird cannot fly. Without legs, you cannot walk. So you require legs to walk. You require wings to fly. Those are requirements. Those are needs. So in our case, our topic is made up of two words. There's requirements. We've already established which requirements. These are needs. Requirements. These are needs. What of engineering now? Nice one, Spanda. What is engineering?
Now, okay, let me try.
Okay.
I believe engineering is the discipline of using what can I say? Using common materials to do a particular task or gathering, or what can I say? Using common materials is a discipline of using materials to build something.
If your definition is correct, what of software engineering?
Maybe software engineering, you'll be using the technologies that are available to build something, maybe software or an application, or in that discipline. If it's mechanical engineering, it's something.
That's okay. Anyone else to give it a try?
Yes, is the application of science and maths to solve problems.
That is engineering. You're just using how can I put it? We can't say maths per se. We're using science.
Scientific method.
Come again?
Using scientific method.
Scientific methods, and you're using science to come up with something. So from those two words, we've got need and we've got building science and science. So there is need for us to come up with the proper. We're coming up with the needs to build something. You understand now the relationship that's there.
Yes, sir.
Yes.
I gave you an example. There is need for us to build a mode of transport and it from point A to point B. And we're going to use scientific applications to us to come up with those needs. So we're building a mode of transport. What's needed? Number one, it needs to have 4 wheels. So that means they fall off. Number two, it needs to maybe have a loading bay, a loading tray to carry, maybe to be able to have a payload of maybe a ton. So which means to my feet and small cars fall off. So that's how you come up to the exact need of the client in a game. Anyway, so to give my definition, they're more or less in your amatipa. Upon Ndakati description describe how a system should act, appear, or perform. A statement in natural language plus diagram of the service of the system to provide an operation and provide its operation constraints. It is written for customers. That is key. It is what written for customers because attribute as I say, the customer. Customer adding to a system which enables me to access a computer remotely. That is what the customer needs. You need to build exactly what the customer needs, or else we'll be assisting you on them for. Are we together?
Yes, sir.
So then engineering is the use of scientific principles to design and build machines and structures. In our case, there won't be structures per se, there will be systems now.
So say, are you still sharing your what do you call it?
My PowerPoint, yes.
PowerPoint. Not school. I mean, not school one.
Pane mumwe munhu asiri kuiona, because I can see it. I've actually logged in using my laptop and my phone.
I
So
can't
maybe
see it
one-
also.
Is there one who's seeing it?
I am seeing it.
I'm also
On my side, it's okay. I'm seeing
seeing
it.
it.
Yes, I'm seeing, sir.
So
This
it's one
side is
person.
this side is not visible.
I'm not.
Ah,
I'm not saying it. It's visible now.
all right. So
I can't
Tessa-
see it.
All right. How many cannot see it? Show by raising hands. Mpume. Who else can see it?
I can't see it.
Obey can't see it.
Yes.
So there are two people who can't see. But the unfortunate part is, all right, it's okay. Let me stop sharing and share again. For the benefit of others. Now everyone can't see anything on this.
Yeah, black screen.
Yeah.
That's fine. Sure. Let me share again. Saka kwaise mamusingaone but makanyarara.
No, said such to maybe Kirungo discuss and then you start to share later.
How about now?
Yes,
Okay.
no.
Yes.
Yes.
Back.
So who can see it now?
On my side is still black screen.
I just give it a little time. I'm sure it shall shika. Pana ari kuone.
Yes,
Yes.
I can see it.
Yes.
Vasiri kuona mpume mwakuona kana kuti hamusati mwakuona.
Ina nini ndakuona ze? Mbuma kuona.
Hola,
Mpume.
Irkuoneka.
All right. Who can't see?
Obey can't see.
Okay. Mpume.
I can see ze.
Mpume, you're okay now.
Yeah.
Obey now. Now I don't know what to do now because vanhu vakawanda vari kuona. Vashoma ndo vasiri kuona because I've restarted. Inini, I can actually see and I'm logged on using my phone and laptop.
Let me try also to log on using my phone.
Yes, no, that's fine. All right, so let us proceed. We can proceed, is it?
Yes, sir, we can proceed.
All right, so tanga tiri paslide rinora handiti. Before you do anything, it's always best to find out exactly what that means. And normally, IT, most of those words are English words. So by virtue of them being English words, which means you can derive the meaning of that topic or that subject before you even jump into the topic. I've seen cases whereby Munano Twitter a course finish out on your exam, but they still have no idea what what exactly that course entails. So I want us to have an appreciation of exactly what we're doing before we even jump into the technical stuff. So that's why I had to define what requirements are, and we had to define what engineering is, because those are the two words that come up that make our course. So, Chiri Papa, are there any questions so far? Guys, are there questions so far?
No, this is for me.
So far, it's okay.
So far, so good.
So we've moved on to the next slide.
I think it's too clear for now.
We've moved to the next slide, which states that requirement specifications. Remember, Tati, what we want to do is to gather, to get what is in the brain of the client on paper. Then we take it to the developers. So we need to find out by exactly, I mean exactly what the customer needs. To build something that the customer doesn't need, you've wasted a lot of resources. And we all know time is a resource, and guys, we all know time is a resource, and
Yes, sir.
Yes, sir.
That's fine. So, what is requirements engineering? Some of you are not by the definition. I'm sure you can go and read the definition. But now our definition is not enough if we don't mention requirements definition. This is now according to Ian Somerville. Ian Somerville, E are not E. Definition. Requirements engineering is a process of discovering, analyzing, and documenting and validating requirements of a system, which means there is discovery part, number one. Number two, there's analyzing. Number three is documenting. Number four is validating. What is the difference between verifying and validating?
When you are I think when we are verifying, we are trying to prove that it is correct. But then when we are validating, we know the correct thing. So we
lost you there for this. Validating, you said what?
Validating. We are validating. We are now sure that this is correct. We are just validating. Simply so writer.
Anyone else? All right, validation is simply came from the word valid.
Yes.
Panonzanzi, your PIN code is invalid.
I think it's wrong.
So we're just checking whether something we're checking whether something is right or not. So basically, Tsukuti, we've built a system. So we cross-check with the client system from what the client is expecting. Then documenting is simply putting everything passing on paper. And discovering is okay. Someone's joining. All right, I think I need to make someone able to allow people to join. Who's your class rep, you guys? All right, it's okay. Let's proceed there. So, gender next slide, and we have requirement specifications. We need to, number one, first and foremost, we need to define the requirements. So by defining now, Trikuti Susu, Z exactly, and like I said before, this is written for customers. Okay, at least one or two. We're defining requirement definition. After requirement definition, we now need what are called requirement specification. From documents, from definition, this is a statement in natural language or plus diagrams, which aids to what? Which aids to explain exactly what what the requirements are kudikanwa by the client or the customer or the key stakeholder or whoever you want to build the system for. So at the end of the day, we want to come up with a proper document that just registers for the development of the system. So after that, you need to have a little scope of it. This is where we're beginning, this is where we're ending. So hence you come up with a definition. Yatawa it's written in natural language. What is natural language, if I may ask? Natural language.
It's just simple English. That's this language used to communicate.
It could be English, it could be Spanish, it could be French, it could be Shona, it could be Tonga. That's natural language entity.
Yeah.
So from there, we go to requirement specifications. From here, it's saying it's a structured document setting out the detailed description of the system services. It is written as a contract between client and contractor. The software must provide means of representing access external files created by other tools. Now you need to come up with some sort of an arrangement between the client and you per se. To say that's a system here. I hope everyone understands John.
Yes, sir.
Right. So in Changi try kuisa maybe a bit of Shona, a bit of Ndebele, although my Ndebele is non-existent, but Tichazama, Titifita and this. So this is now a document. Ramon Sainirana Pakati. At least we're getting
Yes, I'm trying to join a phone young cozy.
Oh, I've accepted. I've accepted. So we're saying this is a structured document. Description of the system services. And it apa manura, the first one was in natural language. Now the system is supposed to do. So more drafted document saying muchinyora exactly what you want your system to do. Well, okay, not your system, what the client wants the system to do. I'll continue coming back to my example, your motor. If you want a mode of transport from point A to point B. Now, it needs to have 4 wheels, have engine capacity of this, loading trade, so now this now has a more detailed description of what the system is going to be, is what the customer expects from the system. So yes. Moving on, the next will be now software specifications. This is a detailed software description which serves as the basis of design or implementation. This is now written for the developer. Zvatanga tichita requirements, specification and definition and it. Client side and it. The client aroda chakati. Now it's also kana takuti software specification and it. Takuenda to the developer. We want the developer, I develop a system, chakati, which operates in this which operates in this environment, something like that. Are we in agreement?
Yes, sir.
Yes, sir.
So Chukuti, Now pachazotanga kuzoita ma-different types ema-requirements. Aripo kama-tips. As long as pane one type of requirements, panofanira kutoita different type of requirements. Inini, I like this diagram. Corona diagram.
Yes, sir.
I like that diagram. It summarizes the life cycle according to some of them. Here, the requirements engineering process. So if you master that diagram, according to me, matopedza course.
Saka takapedza.
Remember, keyword was mastering that diagram. That was the keyword, mastering the diagram. So if you master the diagram, you don't go report. All right, so we've talked about requirements. So now, what are the types of requirements that we have? The types of requirements. I'm sure, but I think that's what matters. Why since Takam as first assignment.
Cinema user requirements
and
a functional requirement.
Inika. Okay. So cinema user requirements, and I've got system requirements.
Operational requirements.
All right. Zvinoitika manje when we're dealing with requirements, it can fall in different categories. Right now, I wanted my requirements, types of requirements, specifications. Atati arguenda copies here?
There's a contract between the client and the...
Exactly. Definition. So I'll ask him to what are the types of
they are
requirements?
Functional and non-functional requirements.
Those are not requirement specifications. Those are not types of requirement specifications.
Cinema business requirements.
But cinema user, the system requirements, those two.
Yes, sir.
So the user side, again, I'm a client, a manager, my client engineer, and a client contractor, and usually based on clients. So my system requirements straight up system end user, my architects, my developers.
Yes, sir.
Oh, okay. You can mute your camera, your mic, so that was in the accident which I bit of noise. So Mina, I told you I like that diagram very much. It's going to make life slightly easy. What do we mean? From a feasibility study, what's a feasibility study? Feasibility study.
A feasibility study, it's a study is it doable?
Is it doable? Checks and balances. Can we do it in the certain time frame at Apiwa? Number one, can we do it with the budget at Apiwa? Number two, and do we need to create a big system for a small company, or do we need to create a small system for a big company? So patrikuita feasibility study muchaona zvenyu nekufamba kwenguva pane zvakawanda zvichange zvichidiwa mufeasibility study imomo. Hello,
we are still around.
Andit.
Yes.
So feasibility and the document that comes from that is a feasibility report. Zoku that I know, the client wants us to build an aeroplane and the budget yake is $200. Hazviiti. And if we're going to come up with a system like that, it will be it won't be a very good system because of the budget and the time and that and the like more. So you need to come up with, before you even attempt to give the system to anyone, you need to check whether it's possible for you to build that system within the specified amount of time. And so from there, there's a feasibility report that is generated. Tichibva ipapo takuenda kune word denotes requirements, word denotes elicitation. What is to elicit? What is to elicit? Guys, this is an English word. What is to elicit? He is eliciting a response from me. Elicit. Guys, come on. You treat something called requirements elicitation. So requirements, we've already established what requirements are. So we want to find out what is to elicit before we even come up with requirements elicitation.
So I think elicitation.
Yes, sir.
But basically, elicitation is what basically maybe in requirement space what is it so basically find out the information.
You're finding out something, you're extracting something. That is elicitation. So upper, we are extracting the needs that are aya. And tati requirement is something that you need.
Yes,
did we agree or we didn't agree?
Yes, we agreed. You said the requirement is a need, something that we cannot do without. It's a need.
Yes. So we want to extract those things that we can't do without.
Yes, sir.
So where do we extract these things, these requirements from?
From the users of the nation, from the users of the system, from the people who are going to use the system, from the customer.
In this case, we need to extract them from the client.
Yes,
client
sir.
is that pabasaka. So it's
Yes.
the basa from the client. The client cannot put the requirements and are in. So that's where we're going to. What about requirement analysis?
Analyzing, we are looking at the requirements that have been gathered or that is extracted, and then we are analyzing. We are actually trying to see can this be done. We are analyzing to see if we have gathered all the necessary requirements.
You've gathered all the requirements, and
yes.
So now when you analyze. That's where you're going to be building, or you're going to be creating graphs and tables and whatnot to figure out just as what it is. At the end of the day, that is the question that we need to answer. From there, we get system models. Remember, a model. A model is just like a plan. Plan a building here. Join a city. You can create a little model to see how the system or how the building is going to look like once it's finished from the client side. And it.
Yes, sir.
From there, topinda requirement specifications. Atambotaura tichibvunzana kuti tine manhigiri mangani, tikati tine mairi handiti. Anova iyo user and what? requirements and system requirements. We further broken them down in that into two. My user requirements, they deal mainly with the manager, coming from the manager. Then the system requirements now, from the developers. Someone, sorry about that. Someone is trying to. Then from Untitled up, Untitled we run requirement specifications. Tatima requirement specifications tissue. Requirements specification. The we run of the key. Requirement specification.
I will run a structured document which sets out the detailed description of the system state.
Ichienda kupi?
Ichienda is written as a contract between the client and the contractor.
Yeah, right. That's good to say. I think this was it. On Makanga. Matokanga because it's a change slide. And in the wire. I see the definition actually get up. Tango slide one patava tato rasika kuti chubita. Just one slide. A structured document, and it set out to give detailed description of the system services. How do we do about that? We divide it into two user system requirements. Then Tambo Punzana, what is to validate? To validate tikatichi. Ndatimbonzwa ino wanasiri mpumi. Tatenda.
Yes, sir.
We agreed. What are Tati validation chi?
To validate validation. Validate from the word valid is to make sure that it is correct.
And it. So from our diagram, you check whether what you want to do is which one of the clients. Is it feasible? Is it doable? And it. We extract and we analyze, then we come up with a simple model. When we come up with a model, after the model, we come up with a detailed report. And it. These are requirement specifications. From the requirement specifications and it, we check whether it is valid. We go back to check with our specifications. What can be changed? What can be altered? The issue yatauya nayo is because of a requirement is not elicit from the client. We move further back until we get to a situation maybe with feasibility study. Okay. Build. Let's say we want to build an artificial intelligence system. Do we have the technical know-how? Do we have the data set? What exactly is the client trying to do? Validation. So now, what do? We go back. Guys, my specifications are right because when we're trying to come up with these requirement validations, taona in anomaly. All right, we'll check our specifications. But no, these specifications are exact from the document which was created and it from okay, if the document that was created is not okay, let's see whether we can make it a change from the document. It's gonna you know what, the Jiripana is correct that change it or not so it becomes a cycle until you come up with a requirement document comprehensive. Are we together?
Yes, sir.
I'll give you, let's come back to an example, Yemunani, 100 US. What 100 US, waenda uchite 100 US kuda kuchinja. Wona ariwopiwa mabonds. Woenda kuna anenge amurungu anditi, ndo inenge iri mbinga anditi. Woenda kune mbinga uti mbinga, ndawana mabond aya. Ota mbinga even ayo ina handisa mabond, ndoda RTGS anditi. Already, patounganidzwa maspecifications asiriwo. Wobva ipapo wodzokera kune mupesa wakuti ano guys, mupesa achada RTGS, haasina mabhondi. Wopa munhu mabhondi ake. Uchibva mabhondi obva upiwa kana let's say upiwa RTGS. Woenda kune murungu, woti murungu, ndaisirwa mari imi iko cash. Mari yenyu ndeiyi chichi. Murungu obva aiwa no, ina handisi kuda iko cash because ndoda kuita a payment. Ndikuda transfer bank. So you see the continuous working inenge ichiitwa between the client and the middleman anova iwewe. It's a continuous system inenge ingoripoti from this to that, from this to that, until you come up with a composite requirements document. Richange richiendeswa kune madevelopers edu. Remember, iwewe one of the system requirements anenge aripo, iwe ukadesign a system inoshanda an Android application system, yet munhu arikuda a system inoshanda pama iPhone. Apa iwe wakagadzira an Android application. So it means that you have missed something. So you need to continuously liaise before you even come up with the system, because it's going to be costly for you to change the system midway or could design something changa chisiri proper kuti uchizochigadzirisa. Example yedu, wagadzira road, munhu arikuda train kana kuti munhu arikuda ndege. So it's going to be costly, it's going to come zvichanga zvakubuda mufeasibility report yako kuti zviri kuda munhu uyu, number 1 time yake, number 2 nebudget yake, number 3 netechnical know-how yatinayo o iripo, hazvibude hazvisi feasible. Ndataurisa stereka.
Aiwa, matanzwisisa.
So it becomes, if you know the how information is going to flow from elicitation to specification to validation, and you're going to come up with this other diagram. I've got just 2 diagrams. I'm going to prepare my diagram. Mogona difference here, this diagram and this diagram.
Yes.
In the diagram, I risk tangira. This one is starting off on the feasibility study, but this one is not.
Yes,
but
sir.
It's what? It's the same thing. So, zvoreva izvo kuti patanga tichiti system ready inofanira kunge, for you to be able to write a proper document, you need to have information, the data that you're going to gather. It needs to conform to some sort of standard for you not to be continuing mislead. So number 1, which means the characteristics of good requirements. Number 1, aripo akawanda diti. It's supposed to be tipewo 3 amunoziva. Just 3. There are plenty. Why? Because as long as you can justify that characteristic of the requirement, then you're on point.
A good requirement should be precise.
What do you mean by precise?
Should not conflict with other requirements.
All right. Can you give us an example of an requirement and conflict?
Okay. Tombot, like in web development and data, and then the client unaware, so suppose arikuda a system, arikuda a contact form, and rekuti kana rapedza kusenda a message, Robert, thank you very much for your message, kana to contact you late, and then the requirement issued not say, I don't know how to explain this. But I know what I want to say.
All right. As precise, it should not conflict with other requirements.
Yes.
Zora is your system ready are not just one requirement.
Yeah, extreme requirements are.
So if you were to build a system, printer a document. which gives rise to printing of, a job, guys, after this I need to print my report. Then the next requirement of it, because of confidentiality, nothing is supposed to be printed.
Exactly.
So those requirements, they're conflicting because they're not precise because one is directly conflicting with the other.
Yes,
Sir. Guys.
Yes, we are together, sir.
So yes, number one, it needs to be precise. What are the other requirements?
Feasible.
Nditatenda ataura.
Nditatenda ari kutaura.
All right. Tatenda tiexplainere feasible, then tombomira neve tonzwa mavoice evanhu.
Okay. Feasible, it means kuti requirement yedu inokwanisa kunge ichiachivika, it should be doable. So we are saying kuti suppose munenge makapiwa ma-resources, inofanira kunge ichikwana ma-resources iwayo amakapiwa, kwete kuti makapiwa ma-resources ekugadzira kafiti but makuita ma-requirements anoda kugadzira ndege.
That is correct. You're given time, let's say mapiwa 2 days to come, 2 months to come up with a system. But 2 months ipapo, put for this system to be made, to maybe 2.5 years.
Yes, sir.
Or more months, all right, try to train this artificial intelligence system. More months, train mapiwa kajuoko.
Yeah, true.
Apa imi mukutora kuti isusu juoko kwa i7 yacho haisitokwana toda HPC apa imomanza oita juoko chiita. Hazvisisiri doable. Make sense because the system requirements and the resources anenge aripo hazvisi kuenderana. So resources dzedu kunyanya, in number one, personnel, vanhu vacho vachagadzira the system. Number two, financial state, mari yamuri kuallocatwa. Number three, the time.
Yes, sir.
Munzi mimi designer a spaceship, inogara space for maybe 3 years and come back. More months out at took by budget $2,000 and it's right in 2 weeks. As just feasible, as story doable.
Yeah, true.
And it. So what are the characteristics of a good requirement? Tatenda tabo chimbopova munkani.
Yeah, ndanyarara.
It should be correct.
Correct. All right. Explain correct, sir.
Okay. The facts related to the requirements should be accurate and it should be technically and legally possible.
That is correct. But in manje, I prefer giving examples because with a definition, Torah straight from the module. So unogona kusanzwisisa exactly what it means. But mukatipa an example Torah said Iowa
Okay, sir. But to correct my facts requirement with one client should be correct. Can I specify here kuti arikuda mota yakadai yakamira so inofanira kunge ichigadzirika uyezve ichiexista uyezve inofanira kunge iri ku political side iri legal.
Legal ne politics zvakasiyana.
Okay.
Legal ne politics mukadatarisa legal ne politics, of course but those are two different things. Okay, you might be asked to design a system which hacks the CIA or the military website or the military database.
Yes.
That is legally agite because it becomes illegal.
Yes.
So that's the illegal aspect. So I'm sure the technical part you can also you're told we want to create a system which uses artificial intelligence. Let's say an Internet of Things system, and it of onesie. Next thing, it needs to have an artificial intelligence capacity. But those are technically two different technologies. Of course, they can be combined, but according to the system it's technically impossible.
Impossible.
Hazviite kuti titi tikuda in internet of things system apa toti taiti yakufana kuva futi artificial intelligence in the present era. I'll check this. My systems that you are making now, and
Yes.
imagine if you were to try to make them 20 years ago. Zvainetsa. It's not good. It was impossible. It was going to be difficult because the technology that was there made things made it tough for programmers to program anything. Munhu akatodesigna chiprogram chinonzi Pac-Man chaicho akatowina ma-awards. You know game inonzi Pac-Man handiti? Akatowina ma-awards mufirst year, but right now tikada kuti Pac-Man tikakuchidesign again Pac-Man munokwanisa kuidesign. Develop. So hence, it's depending on that, it becomes technically impossible to create some of the things. What other requirements, characteristic of good requirements?
Also, the requirements must be unambiguous. That means each and every requirement must have exactly one meaning. We mustn't, after seeing a requirement, think that it means this, yet it means the other thing. Let me try to give an example. I don't know if you can hear me.
Yeah, yes, we can hear you. We can hear you loud and clear.
Let me try to give an example. Let's say, for example, our requirement is saying like the system, maybe when entering a password, the system mustn't allow user to enter a password that is more than maybe 5 letters or 5 characters. But that is ambiguous because it doesn't state what must the system do after the user enters more than 5 characters. Must it terminate at 5 characters? Must it close down, or must it ask the user to re-enter the password with the minimum of?
That is correct. Imagine having a requirement. The thing should have wheels. How many wheels? How big are these wheels? High square pressure, it's all rubber. So it becomes ambiguous now. You get a system requirement like database should have at least let's find a more technical example like the one that you gave. I like dealing with artificial intelligence. Sorry guys. So most of my examples are related to artificial intelligence. You asked to build a system with artificial intelligence which analyzes diseases. That's a very ambiguous statement. What disease? For which is it plant? For which plant? For which is it animals? Are they people? It's just ambiguous. It's not accurate. It's not straightforward. All right, welcome to new members. Anyone to give us an example? Animal module menu man. Hello, guys, module.
Yeah, tikukunzwa izeni.
Animal module, there's a handful. For module, but panic because I'm asking you to explain and give an example.
But
Requirements must be independent, if I can say. Like, for example, each and every requirement must be a standalone. It mustn't need another requirement, right? Or to describe it like.
Okay, can you give us an example? Because I'm not getting you properly.
Let's say, for example, what can I say? Let me try to find a perfect example for you. Like, say, for example, we have the requirement that says maybe, let's say, for example, the list of flights and their numbers, departure time, arrival time. And let's just say for example, in the other requirement, your variety is to be sorted by price and so
You're breaking up. I'm not hearing you properly, sir.
We are having two requirements. Let me say requirement number one. Let's say, for example, is for the list of available flights and digger. That shall include flight numbers, departure time, arrival time, and the likes and digger. Then the second requirement, which is requirement number two, it should be sorted by price. That simply means a requirement number two is dependent on the requirement number one.
Is that a bad thing?
You said,
I'm asking, is that a bad thing?
yeah, it's a bad thing. Requirement, each and every requirement must be a standalone. It mustn't depend on the other requirement, if I can say.
Right. I'll come back to our issue of mode of transport. Requirement number one, the car should have an engine, a diesel.
Yeah.
Requirement number two, the car should be a 3-liter engine.
So I think those two must be on one requirement.
If they are on one requirement, they can tend to somewhat conflict or number one, they should be simple, but easy to understand.
Yeah.
Say,
Yes.
but then when it comes to changing that requirement, which is dependent on another requirement, also change the other one. Will that raise no problems?
No, definitely it's going to raise problems, which is why when you're coming up with your requirements, that's why it's a loop. Remember, uchacheka whether these stations are kwakanaka. Pauchenda validation, unataka wanakanganisa paka kanganisa. You can still go back and change certain requirements. There's no limitation to the number of changes that you can make before you come up with your requirements document. There's no limitation. It's a loop.
Yes, I said they should be independent. Because in chazongudzoka ndichiti requirements enyaya anozopinda bits kana kuda kumachinja ngaaite independent asave dependent on each other.
Okay. What is just because my requirements, this requirement is dependent on the other, shall affect a system when you're developing the system. Because it seems names through database. All right.
No, we are just being.
Let me give you an example. Requirement number one, my system should be Android based. And let's agree, it's a system you talk about Android.
Yeah. Yes, sir.
So Pogadzero an application which runs on anything that is upgradable per operating system. Because Android and it's jelly beans, nana cheese, my versions are wanted.
Yeah.
So the other requirement could be it should be robust enough to package for an upgrade. So requirement number two is dependent on requirement number one. I don't think okay. It all depends on how you want to go about it. But for me, I don't think there's much of a problem if one is dependent on the other. Because bear in mind, system that the client wants you to design, it has certain functions. My functions are actually like it should have a database, number one. Number two, it should generate reports. So reports are going to come from the database. So one is dependent on the other, whichever the case. So I don't know maybe how you're going to answer that question, but I gave you an example.
What I'm saying here is, I think, I'm understanding you. I think it depends on the type of requirements or what we are trying to achieve with the requirements. there is a time that when we change once we change one requirement, then the other requirement that is dependent on that requirement won't be understandable at the end of the day.
Yes,
So
it's like the example that I gave you. The software should be running on Android, number one. The other one should be the system should be robust enough to change with an operating system. So which means if you change the requirements, could each runner on an Android based system, each runner on Apple devices, or let's say Windows, it means that other requirement is going to change also.
okay.
Yeah, but the way I might say it's fine. It could also change. It won't be really dependent on which operating system, because we got operating system. But let's say with Nagati, we need to update which is later the latest Android system, but since a change to iOS, then that comes a problem now. With Android with iOS, so which one is it? With an ambiguity, other problems, food and get a face. So maybe it depends the manual running as a core requirement that you know.
Yes, and number one, it's written in natural language.
Yeah.
But avatars of the property that it's going to be a structured, specific, detailed document. So when you're coming up with a specific detailed document now, don't want to work on notice some of these things. And not already, and it. These are characteristics of a good requirement. Already started I imagine more of the system in my clients. You're bound to have some of these discussions. And when you're bound to have some of these discussions, if it is not iterative, if it's not a cycle, it is going to be difficult, which is why requirements engineering life cycle. So before you come up with a robust and a complete requirement document, there are certain things that are expected. It's very difficult, or it's very rare for you to come up with a requirements document. Feasibility study, to end up illustration, total specification, total validation, total document. It's not going to be like that because things change. You can design a system per Windows 10. Right now, it's on Windows 11. And all right. Anyway, so let's not veer off course. That is okay. Characteristics. Let's that one among are not Pama characteristics. Wonder, guys. Feasibility, necessary, correctness, concise, ambiguous, complete, precise, verifiable, traceable, allocated, design implementation, non-redundant, assignment, unique identifier, void from escape clause.
So let's take a necessary.
Necessary, George. I thought that was the first thing that we were going to say. Necessary. Prioritize.
Yeah, exactly. And also we also a requirement said to be unnecessary if taking it out or removing it from the document or from the requirements won't change anything.
What changed the system or how it operates? So that I thought that was going to be the first one. I'm only around. That's what I thought, because if you have a requirement that's unnecessary, then you can remove it and put it back and still won't affect how the system works. Can I have an example of an unnecessary requirement?
On the example, let's say you're tasked to design a car, then vanogona kutoda maseats ano-vibrator kana kuti massaging seats, but before maita the basics zvakanaka nemakutorequire kuti muite zvemaseats iwawo, anozoti paine budget constraint kana kuti anopedza time before maita the basics that need to be done, the car is ready.
So vibrating seats are unnecessary to the function of the car. Whether the car has vibrating seats or not, it is still going to travel. You understand?
Yes, sir.
Whether tamabis can't come at Drosera. functionality of the car won't change. Anyway, anyone else? Let us have two more. Guys, since I want this, guys.
There must also requirement must be abstract also, or I can say maybe implementation free. Like the requirement documentation mustn't include unnecessary design implementation information. Like say for example, saying maybe like the information must be sorted in text file, or maybe must be stored on a disk or something like that. Those are just unnecessary.
But mind from your example, those become necessary. Why? If you're trying to create if you've got a database and you say we're going to have a backup and these are going to be stored in an external device, that becomes necessary.
Is it?
Because when you want to export and you understand concept here, backup and it.
Yeah.
Right, origins grandfather, father, son, chichi.
Yeah.
Guys, did you do this? This is a recap. You did this. And so backup, if backup is in the same building, it's not properly backed up. It's not properly backed up. If it's in the same town, it's not properly backed up. Some further will go further to say if it's in the same country code, same country, it's not properly backed up on it. So it's just good if it doesn't have the requirements to say back it up in an external device or back it up somewhere, then it means that the purpose of it being backed up Right. For the purposes of time, that's I saw. Concise. Requirements should be stated simply. Simple language. Kuda kuisa flowery language kuratidza kuti ini ndakadzidza kuharvard does it simply creates a lot of problems pane munhu muchiisa zvimawords zvenyu zvana flabbergasted nana chichi zvaizvo. It needs to be simple so that everyone who reads it can properly understand exactly what you need to say. The other requirement is complete. Anofanira kustate exactly what you want done. Tambopa an example yamama kupa muchiti hanzi kana image is dependent on the other. But if one requirement is stated completely and you're not going to be facing some of these challenges that we're going to among us arise. So you are complete, you enter paside. All conditions under which the requirement applies are stated, and it expressed a whole idea or a statement. Remember, our requirements are not. It's not going to be a statement. Car wheels, 4 wheels. It could be a brief explanation on how those things are to be done. Verifiable. One interesting one, devoid of escape clause. Language should not include phrases like if, when, but, except, unless, and although. You understand why we don't need those words?
Yes, sir.
It becomes tricky if you say, okay, if system does this, then this we can't be using those words. It should be concise, simple, so that it's easy for anyone who's going to read your document to understand. Guys, I think I'd scheduled from 9 to 11, and I've got something to do at 11. So this marks the end of our brief first tutorial, but we are going to have more tutorials before you get into the exam, because I know you know that